Hello class, in this lecture we are going to be learning about air pollution, climate change, and ozone depletion. Now some of these topics you may have already heard about. Climate change, for example, you may have read articles about it, you may have heard news stories about it, you may have heard about it in politics a lot. But in this lecture, we're going to start from the very beginning. As if you have no previous knowledge, we're going to just go over each of these topics, and we're going to cover it the same way that the textbook does, and you'll get some opportunities to learn more about climate change in an upcoming discussion board. So you'll get a chance to learn more about it and form your own opinion. Okay, so let's go ahead and start with air pollution. What is air pollution? When we hear that word, we immediately might picture something like this. We might picture smoke in the air. But air pollution refers to any form of a gas that's contaminating the atmosphere. So it doesn't necessarily have to look as dramatic as this picture, but anytime there are small particulates that are contaminating the normal composition of the atmosphere, that's referred to as pollution. And we group them into categories. We have primary pollutants. Those are sort of the large or more common ones. And then we have secondary pollutants. So we're going to go over those different categories of the types of gases that can contaminate the atmosphere. When pollutants come from a building or maybe a manufacturing site, we would consider those to be stationary sources of pollution because they're not moving. So if you look in the back of this picture, you'll see sort of a small building in the back, and you'll see pollutants being released into the atmosphere from a stationary source. A mobile source, a great example of that would be something like the red SUV in this picture, where as the SUV is traveling, the pollutants are released into different parts of the atmosphere depending on where the SUV is going, right? And so it doesn't necessarily stay in one stationary spot. Air pollution can also come from agricultural sources, so that has to do with things like the pesticides that we talked about previously. Those can be sprayed into the atmosphere to fall onto the plants and to reach the soil, but it also travels through the air. And so a lot of agricultural pesticides that are sprayed can actually contribute significantly to air pollution. And then there are also some natural sources of air pollution, like for example, if you look in the back of this photo, you'll see a volcano there. And so there are natural parts of an ecosystem that can contribute to pollution as well. When we look at pollutants, we actually group them into primary and secondary categories. So we're going to go over some of the primary sources of pollution. So in this same picture, you're seeing some common air pollutants in the cloud there in the atmosphere. You can see some carbon monoxide, some nitrogen oxide, some sulfur dioxide, small particulates, little things that can be suspended in the air. Sometimes that can even include lead. Those are all really common sources of pollution. All of those were outdoors. What about indoors? Well, inside a building, you can also be exposed to pollution. Sometimes that can be because of poor ventilation, where the pollutants aren't being removed from the circulating air in the building well, and then sometimes people can really suffer from some sick building syndrome symptoms. So sick building syndrome is when people in a given building are exposed to those indoor air pollutants, and then they start to feel a little sick. They can sometimes have a lot of headaches. They could have itchiness maybe in their nose and throat. They could have a hard time breathing. And so sick building syndrome really is focused on just pollution that happens inside of a building. Another type of pollution that you can sometimes experience inside of a building is if people have been smoking inside of the building, so secondhand smoke exposure is another source of indoor air pollution. Now we're going to shift from talking about sources of pollution to now thinking about what protects us when we look at the surface of the Earth. So if we were to think about the sun produces a lot of harmful UV rays. So those UV rays are referred to as ultraviolet radiation. So if you picture the sun and imagine the ultraviolet radiation coming off of the sun, the Earth would be absorbing all of that ultraviolet radiation. But the ozone protects the surface of the Earth so that we do not absorb all of the harmful ultraviolet radiation. So the ozone is a protective layer. I sometimes tell students that you can imagine it kind of like a Band-Aid. So if you were to think here of Earth at the bottom of the picture, and then there's the layer of the troposphere. Now if you imagine kind of like a Band-Aid going over the Earth, now you could imagine the sun not being able to penetrate through that Band-Aid so that it's protecting the Earth. So the ozone is a really important way that we have protection from harmful radiation. And we know that exposure to excess ultraviolet radiation is a really common source of cancer, right? So we want to decrease the ozone. We want to decrease exposure to ultraviolet radiation by protecting the ozone. So how does the ozone actually form? Well, it's made from oxygen gas. So oxygen gas actually gets broken apart. So let's take a look at that molecule. So these two red circles represent oxygen molecules, and when you're breathing, even when you take a breath in right now, oxygen molecules are floating in the atmosphere. But those oxygen molecules actually get ripped apart and they rearrange themselves. Rather than arranging themselves into groups of two, they clump together as groups of three. When they do that, they are no longer referred to as oxygen gas, they're now referred to as ozone. So O2 is described as oxygen gas, O3 is ozone. So that protective layer is made up of O3, which is three molecules of oxygen bound together. So unfortunately, due to pollution, the ozone, that really nice protective layer around the Earth, is actually decreasing. It's getting depleted. So why does this happen, or how does this happen? Well, there are molecules called chlorofluorocarbons. They're abbreviated CFCs for short. And those chlorofluorocarbons get emitted into the atmosphere. When that happens, they actually destroy the ozone. So remember we said you could think of the ozone kind of like a Band-Aid that's protecting us? Well, now imagine something that goes through and pokes big holes in the Band-Aid. So now the Band-Aid can't really protect anymore because it's really depleted and it's kind of ruined. That's what you want to think of. That's what's been happening, is that the ozone was getting really, really depleted. So the presence of chlorofluorocarbons have caused holes in the ozone layer. And in those holes, those spots of the Earth are not being protected from the ultraviolet radiation. So it's not necessarily that it's completely gone in that area. It's more like the ozone is really too thin to be protective. So that thinning of the ozone has happened all across the Earth. In some spots, it's become very, very thin. And why is that dangerous? Why are we concerned? Well, in those areas where the ozone is really thin, then we're exposed to a lot of UV light. And extra exposure to UV light, if you're not, for example, wearing sunblock or you're not protecting yourself, then it actually damages the DNA. And that can ultimately lead to problems with cell signaling. It can lead to apoptosis, which is cell death, and then ultimately it can lead to things like tumors growing, cancer. So it's really important that we have the protection of the ozone so that we're not experiencing large amounts of ultraviolet light exposure. So here's a picture that kind of goes over what we just talked about, which is how the ozone protects the Earth. So here, for example, at the bottom of the picture, you can see the Earth, and you can see the surface of the Earth here, and you can see chlorofluorocarbon emissions increasing, and then those cause little gaps or little holes in the ozone. Here you can see this little hole, and notice that where the hole is, the sun can shine straight through and hit the surface of the Earth, meaning we receive all that ultraviolet radiation. But where the ozone is present, you'll notice that we receive less of that harmful radiation. Now, it's not a perfect cover, but the ozone helps block that harmful radiation from hitting the surface of the Earth. So it's really important that we don't let more of these holes or more of the depletion take place. We want to protect the ozone because the ozone will protect the surface of the Earth. So hopefully the previous slide helped you to see why the ozone is so important and why destruction of the ozone can be so dangerous. And protecting the ozone is really something that globally everyone agrees with. And so in the late 1980s, the Montreal Protocol was an international treaty that was signed where many countries came together to say, let's not use any chemicals that will deplete the ozone. We don't want that layer to get thinner. We want it to protect the surface of the Earth, and let's get rid of those harmful chemicals that could deplete the ozone. So a lot of them have been removed, a lot of those harmful chemicals. And so the Montreal Protocol is really a success story because for the most part we've been able to get rid of a lot of those harmful chemicals. There is still some work to be done where countries that have extra would be able to contribute to the development of technologies that could help developing countries phase out some of those harmful chemicals. So when we look at the Montreal Protocol, it's an example of a treaty that has actually really improved things globally. So after the Montreal Protocol, the amount of chlorofluorocarbons, which are CFCs, has decreased, and then the ozone has actually improved. So it's not been getting thinner, it's actually restored. So spots where chlorofluorocarbons were used at a very high amount prior to 1980 compared to today, we actually can see improvement in the ozone. So it's really a beautiful example of when countries have come together and actually made things better. And this isn't a solution to all of the environmental problems, but this is an example of where countries came together and good results have actually been visible. So let's take a look at them. So here is an image of the surface of the Earth in the 1970s, and here is an image of the surface of the Earth from 2020. And so you can see that the ozone cover here, or the ozone concentration compared to 2020, where you can see it's much improved. And so a lot of scientists have worked on models that show what would have happened if we had not had the Montreal Protocol. And the idea is if we had not, the ozone could have been much worse and could have been completely destroyed. So the next section of your textbook covers acid rain, and acid rain is material that's made from those same pollutants that we talked about in the earlier slides, things like nitrous oxides, sulfur oxides. The difference here is that when it's in the atmosphere, it actually contributes to what's in the clouds, and then when it rains, that pollutant that was trapped at the cloud actually is released in the form of water, right? And so then you get water falling on the soil that's high in concentrations of sulfuric acid, nitric acid, and when this acidic water hits the soil, it actually causes the soil to become acidic. So much so that that acid can actually kill organisms in the soil, and it can be really toxic. And it's also referred to as acidification. And so acidification is when the acid rain is contributing to the destruction of the soil, erosion of certain forms of rocks and stones. So overall, we consider acid rain to be a really negative byproduct of pollution, because pollutants from the atmosphere end up being below the surface, right, in the soil. The next section of your textbook is talking about global climate change, and climate really changes from year to year, but when we look at long-term data, especially over decades, what we find is that the average annual temperature, and this is across many different continents, is increasing. So you could have a hot day here or a cold day there, but if we take the overall annual average temperature and we compare it to previous years, they're getting warmer. And so as the temperature gets warmer and increases, there are a lot of effects on ecosystems, and there are a lot of effects on our atmosphere and the climate. Even the amount of rainfall has changed. So in the upcoming slides, we're really going to try to go over what is climate change and what is it actually referring to, and why has the temperature gotten higher. So when we refer to our global climate change, we really want to rely on scientific evidence and look at what caused it, and most scientists agree that a lot of it has been anthropogenic, which means that it's a human cause. So what are humans doing that causes changes in the climate? Well, the number one thing that we do as humans that contributes to climate change is burn fossil fuels. Now, fossil fuels are things like coal, oil, and natural gas. So when we burn coal, oil, and natural gas, we produce greenhouse gases. And we're going to go over this a little bit more, but the production of greenhouse gases is what leads to climate change. So what are greenhouse gases, and why are they causing climate change? Well, greenhouse gases actually absorb heat. So if you were to envision a greenhouse gas, you could think of it kind of like a blanket. And if you wrapped up Earth in a blanket, it's going to get warmer, right? The temperature is going to increase. That's kind of how greenhouse gases work. They increase the temperature. The greenhouse gases wrap around the surface of the Earth like a blanket and make it warmer. The more we use fossil fuels, the more greenhouse gases we produce. So that means that if we use fossil fuels more, we will automatically get more greenhouse gases. So what are the fossil fuels? Well, they are coal, oil, and natural gas. So our dependence, every single one of us depend on coal, oil, and natural gas for our daily life. And as we burn these fossil fuels more and more, we're increasing our greenhouse gases. So in the last 60 years, globally, we have all been using more fossil fuels, which has led to more greenhouse gases being released into the atmosphere. So what you're seeing in this graph is a depiction of how much carbon dioxide has been in the atmosphere. So carbon dioxide is an example of a greenhouse gas. And the amount of greenhouse gases that we have today, way up here, is higher than it has ever been for centuries. So the amount of greenhouse gases is increasing, right? Which is that warm blanket, right? So it's making the Earth get warmer and warmer. So let's kind of go over just what we've gone through so far in the previous slides. Let's kind of try to review it together. So when we burn fossil fuels, things like coal, oil, and natural gas, as they burn, they react with molecules in the atmosphere, they react with oxygen, and they produce greenhouse gases, things like carbon dioxide, methane. As those gases increase, then the greenhouse gases, they absorb more heat energy, and they're like the warm blanket. And as those gases increase, these greenhouse gases get more and more and more, then the temperature increases and increases and increases. So this is really the phenomenon that's responsible for global warming. It's the increased use of fossil fuels leading to increased greenhouse gases, which lead to an increase in the temperature. So if we were to take a graph of temperatures from the 1880s, which are available in almanacs that stored the daily temperature, if we compare the temperature in the 1880s to the temperature in 2020, and these are annual temperatures, meaning it's an average taken every day over the whole year, the global temperature has been increasing, right? And again, it's not by huge amounts, but scientists note that these small increases in temperature could be catastrophic later. So the Intergovernmental Panel on Climate Change, the IPCC, does a lot of research and makes efforts to write out reports that basically categorize and catalog all of the information that they go through and research. And the IPCC results are really conclusive to say that our global climate is changing and it is getting warmer, and the source of that warming is anthropogenic, meaning it's a result of human activity. So when we look at the atmosphere and we know that there's more methane and more carbon dioxide and more of the greenhouse gases, what does that result in? What are the consequences of that? Well, number one, the temperature increases. Number two, the amount of rainfall and precipitation really changes. And as you increase the temperature, the ice melts, right? So the polar ice caps are melting and becoming smaller. As they melt and increase the sea level. So that ice melts and then the sea level rises. And the oceans are also becoming more acidic, so increasing amounts of greenhouse gases lead to increasing quantities of sulfur dioxide, mercury dioxide in the atmosphere, and that then leads to more acid rain. So ocean acidification is a really important consequence because as the temperature gets warmer, the pH decreases, and so it becomes much more acidic, and that leads to a difficulty for a lot of marine organisms to survive in really acidic water. Just like we wouldn't want to be soaking in a strong acid, a lot of marine life has been negatively impacted because of the acidification of the ocean. So here you can see on the left, on the top picture, a really vibrant coral reef with really healthy fish, and then you can see another picture where the water has become more acidic and a lot of marine organisms have died as a result of that acidification. What else has happened as a result of global warming? Well, as a result of climate change, the insects that carry diseases have also increased. The viruses and pathogenic parasites that they have inside of them also increases. And so scientists have noted that in areas that are experiencing a lot of climate change, that the spread of diseases increases. So, for example, dengue fever has increased as a result of global climate change. So when we consider our own life and how have our lives been impacted by climate change, that can vary from person to person, but overall, society needs a stable climate to really thrive. And so as the climate gets warmer and warmer, that can change how our plants grow, that can change how marine organisms survive, that can change our food supply, that can change our sources of electricity and power, and that can really change the balance of our ecosystems and ultimately our human health. So when we consider climate change, it's a really important issue, and it's one that you're going to spend a little bit more time studying and learning more about it in an upcoming discussion board, and you'll get some chances to really communicate with one another and then share your views about climate change. And you're not necessarily expected to all agree or all have the same opinion, but the more you read and the more you learn about it, the more educated you can be. And hopefully what you can do as a result of learning more is really make educated decisions on your own choices that impact the ecosystem around you. You can make choices that change how you use energy. You can make choices that change your own consumption of resources that contribute to increased greenhouse gases. And we're going to talk about that more in our upcoming lectures. So hopefully you've learned some more about climate change. You may have already known some of this material, but if you have questions about anything that we went over, I look forward to hearing from you, and I would love to answer any of your questions. And if